Okay, we're live? All right. Hey everybody, I promised that we do one problem from the homework, so here's problem 6. Number 7 is just like it, so if you watch and learn how we do this, number 7 should be pretty easy. Okay, we've got a scenario where we've got two friends are going to call a third friend, and they're going to call somewhere between 7 and 7:30. Okay, so we've got friend A and we've got friend B, and they both agree to call between 7 and 7:30, so I've got that lined out in my graph. You could just as easily say from 0 to 30 minutes, if that works for you. You could just take away the 7 and you've got it, and I can do that right there, and that makes it, I think, just a little bit easier. And so friend A is going to call anywhere in between, and so if they call at 10 minutes after the hour, that'll be right there. 20 minutes after the hour, or 30 minutes, it'll be along there. The other friend along this axis. So just like before, this is the region within which all of the different calls, combinations of calls, might occur. Okay? The problem is that whoever calls first, you're going to expect to talk for 15 minutes, and we want to find out the probability that the two calls will overlap. Okay? So that's really the problem. So if friend A calls at the 10-minute mark, and you go like this, well, the other friend, if they call at the 10-minute mark, they're going to directly overlap, and the 20-minute mark here, they'll still overlap. So we want these two calls, A, and then if we subtract the B number, that's got to be less than or equal to 15 minutes to get the calls in. All right. Well, this is one of the few cases, I think, in math where writing an equation and graphing from the equation is actually a little bit harder than just sort of looking at your graph and thinking of it more visually. So I'm going to go back to that strategy right here. So just imagine, like we did in the other problems, only where can friend A call and have it be okay for friend B to call. All right, so if we start, if friend A calls right at the very beginning, all right, right here, then friend B, the earliest they can call would be at 15 minutes, halfway to 30 minutes. So that's like a boundary point right there. The same way as if friend B calls right away at the beginning, friend A has to wait 15 minutes, and there's the other boundary. Anywhere close, where they're close to being the same time, is not going to work because they'll be within that 15-minute period. If we do the same thing here, if friend A calls at the very end, at the 30-minute mark, friend B should have called by the 15-minute mark in order for that conversation to be done by 30 minutes. So that's the other boundary. So if you look at this, we always wind up with a pattern like this, where this is the okay place to be because their numbers are different. And this is the place that's no good because their numbers are too close to being together and they're going to overlap. So if this is a 15-minute time and this is a 15-minute time and this is 15 here, whoops, and this is 15 here because it's all 30 minutes, then it's relatively easy to work out the probability. Okay? The entire square, like we did before, is going to be 30 squared. These two regions together are 15 by 15. In this case, there are two of them, so we can just think of that one as being brought down to right there, and that's going to be 15 squared. All right? So if you do the math, that's going to be 225 over 900, and it's going to be exactly 1/4. Okay? So there's a 25% chance that they're going to be good. There's a 75% chance that they will overlap. So in this case, it's 75%. All right? Hope that works. Thanks a lot.